So in this ACT hack, we're going to talk about how figures are almost always drawn to scale. A lot of times your geometry teacher will tell you, don't assume figures are drawn to scale. Well, in actuality, in the ACT math section, about 99.9% of the time, they're drawn to scale. And the rare occurrences where they're not, it'll usually say in the instructions, these figures are not drawn to scale. So one strategy you can use that I tell students about all the time, especially if they've forgotten some geometry, is essentially use your estimation skills and guess the angle. And I will go and tell you off the bat, this strategy is a little easier to do when you actually have this on paper. Although if you have a touchscreen computer, this works as well. So the question I'm looking at right here is number 37 from an ACT. And of course, we know there's no guess the angle questions on the ACT, but this essentially is what the question is asking. It's asking, what is the measure of this angle as it is a part of this larger diagram? So what I always tell students to do is, okay, we've got this angle, and if I don't know how to do it the quote unquote right way, is I'm going to make an educated guess. And for a frame of reference, I'm going to draw this line straight up and down. So it's now a 90-degree angle. And you can kind of see this angle measure appears to be more than halfway toward 90. And basically what I want you to do right now is make an educated guess how big you think that angle is and circle the answer off to the right. Hopefully at the very least you are able to eliminate A and B. And so this is an example with a guaranteed guessing strategy you don't necessarily want to use because I've eliminated two of the answers and now I have a 1 in 3 chance of getting the question right. So let's look at what this actual question is. It's this big, long, ugly problem. Bonus ACT hack. If there's a diagram, skip to the end of the question. Most of the time, the diagram, all the information that's in the diagram, they're just repeating it in words, and you're just wasting time basically reading this problem. And you can see ultimately they want us to find the measure of angle C. The mathematical way to do this is you recognize that these two triangles are similar because they do give us that information in the problem. But you can probably just look at the diagram and tell that these two triangles are proportional. So that means both of these triangles are isosceles. We know there's 180 degrees inside a triangle. So 180 minus 42, which is the known angle in this problem. That gives us 138, and then we're going to divide 138 by 2. And that gives us 69 degrees for angle F and angle D, which has to be the same for angle C. So that's our answer choice. Let's practice one more of those. Try to do this one on your own. Pause the video, make a quick guess, eliminate bad answer choices. Hopefully you drew the 90-degree angle so you can kind of reference this. And again, to me, this looks like it's at 45 degrees or less. But 15 seems a little bit too small. So I've narrowed this down to a 50-50 shot. Now let's look at what the actual question here looks like. This is the actual question. So not, if you know your geometry, not a terribly difficult geometry question. Measure of angle ACB is 80 degrees because it's a linear pair with the 100-degree angle right here. And now we have two angles inside a triangle to find the third angle inside a triangle. I know there's 180 degrees in a triangle, so subtract 80, I subtract 65, and you should get 25 degrees as your answer. Let's look at this last question and note what number this is. The questions on the ACT generally get progressively harder. This is a pre-calculus question, one that a lot of students will miss. But the ultimate question, it wants to know, okay, what is the distance from A to B? So we're trying to find that length right there. And you can see some of the answer choices right here. But we need a frame of reference. We got to figure out, okay, to figure out how long this red segment it is, we need to know the length of another segment. Well, I can see this segment off to the left here. I'm going to do this in purple. It's my wife's favorite color. So the length of that purple segment goes from 0.3 to 0.3. So that means each part of this purple segment is 3 units, which means the full length is 6 units. So if the purple segment is 6 units, think about how long that red segment might be. Pause the video, make a guess real quick, and I'll tell you what the right answer is. At the very least, you should be able to narrow it down to C or D. Like, 6 isn't the right answer. 3 and 2.4 both appear to be too small. Well, in fact, it can't be 3 because each one of these smaller distances is 3. So just using that fact alone, 4.8 really is the answer. We won't go into the math behind that on this question, but use that estimating strategy on a question like this.